So in this video, we will be discussing the concept and the field of thermodynamics. So define natin siya. We will then focus on chemical systems, and then we will identify the different elements of thermodynamics. Okay? So as defined, thermodynamics is a branch of physics that deals with the energy involved in any physical processes. So kahit anong mga process yan, meron siyang mga involved na energy. Meron siyang energy of spontaneity, kung nangyayari ba siya ng kusa o hindi. Meron siyang energy of change, depende dun sa particular change na ina-undergo niya, physical or chemical reaction. Okay? Meron din siyang mga equilibrium properties. Okay? So sa thermodynamics, ang dinidiscuss lang natin dito ay changes from the initial to the final state or from one state to another. Hindi natin dito pwedeng i-define yung time that it will take for the change to happen. So yung time it will take from state 1 to change into state 2, hindi natin yun matatakal dito kasi thermodynamics does not concern itself with time. Ang concern lang niya is kung paano nangyayari yung change at kung ano yung mga energies that we can associate with that particular change. Okay? So sa chemical thermodynamics, it will only involve systems that involves a chemical reaction and physical transformation of your elements and compounds. Okay? Since this is physical chemistry, yun lang muna ang i-focus natin dito sa study natin ng thermodynamics. So there are certain elements of thermodynamics that you need to understand. So for example, the concept of state functions. Okay? So ano nga ba yung state functions? State functions or variables are parameters that depend only on the initial and the final state. So, ang definition lang nila usually ay delta. Okay? So, kapag nakita ka ng delta sa isang particular variable or function, it's most likely a state function. Okay? Kasi state functions do not have an absolute reference. Usually, ang reference nila ay defined, depende lang sa state. So, how do we illustrate a state function? So, for example, pressure. So, how do you convert 1 atm to 2 atm? Okay? So, from 1 atm to 2 atm, you can just add plus 1 atm. That's a possible path. So, 1 atm plus 1 atm, you just have 2 atm. So, ang delta P nun ay 2 minus 1 because this is the final state and this is the initial state. So, 1 atm siya. Pwede rin naman tayong mag-path 2. So, magdagdag tayo ng 10 atm. I-compress natin siya to 11 atm. And then, mag-reduce tayo ng pressure by 9 atm. Makukuha natin ay 2 atm pa rin as a final state. So, dito, 2 steps yung path. Dito, 1 step lang yung path. So, either path, okay, 1 atm pa din yung delta P. So, the concept or the parameter pressure is just a state function. So, hindi siya nakadepende dun sa intermediate paths. Nakadepende lang siya dun sa initial and final state. So, that's why the delta P is the same regardless of which path you choose to take. Okay? So, next, okay, is a path function. So, path function is a particular function that depends on the way you change from state 1 to state 2. Okay? So, in this particular example, mag-change tayo from P1 V1 to P2 V2. Okay? So, from P1 to P2, V1 to V2. Siyempre, yung pressure and volume, they are state functions. Kasi, delta P is equal to P2 minus P1. Delta V is equal to V2 minus V1. Okay? Those are state functions. Kasi nakadepende lang, again, sa initial and final states. However, the way you change each parameter, meron tayong particular function na babago rin yung value depende sa kung ano yung uunahin nating palitan. Okay? That is work. So, what is work? So, work is PV. Okay? So, that's delta P times delta V. So, yung work natin ay pressure times volume. Kasi, it's related to force times distance. Okay? So, if you multiply force times distance by, okay, so force times distance, okay, i-multiply mo siya ng area over area. So, force over area is pressure. Okay, so distance times area is volume. So, that's work. Okay, ganun din yung ating magiging result. So, dito sa inuna kong bawasan yung pressure. So, negative delta P. Okay, so ang mangyayari dito, magiging P2 V1 muna siya. So, constant volume, decrease in pressure. Ang tawag doon ay isochoric decrease in pressure. So, later in this course, malalaman natin yung mga different terms na yan. So, P2, V1 muna siya. And then, we increased the volume from V1 to V2. So, nag-increase yung volume niya. So, the work is the integral or the area below this particular line. So, area under the curve. Okay, so that's integral of PdV. Okay, so this is the integral of PdV. So, dito naman, sa kabila, inuna kong i-increase yung volume. So, magkakaroon ka muna ng P1, V2. So, dito, same pressure, increase ang volume. Ang tawag naman dyan ay isobaric increase in the volume. So, magkakaroon ka ng P1, V2. And then, you decrease the pressure, magkakaroon ka na ng P2, V2. So, kapag inuna kong i-change yung pressure bago yung volume, this will be the amount of work that I need to perform or that I need to spend para ma-change ko yung parameter from P1, V1 to P2, V2. Pero kapag inuna ko yung volume change bago yung pressure change, mas marami yung work na required. Okay? So, mas mahirap gawin yung volume change muna bago pressure change kaysa dun sa pressure change muna bago volume change. Kasi, obviously, they have different work requirements. So, work is a path function. Okay? Nakadepende sa kung ano yung uunahin mo baguhin. So, that is how you illustrate a state function and a path function. Okay? So, a state function, again, depends only on the initial and the final state regardless of how you did the process. A path function is the function that changes value when you change the way you do the particular process. Okay? So, in this case, inuna ko yung pressure decrease bago volume increase. Tapos, dito naman sa part na to, inuna ko yung volume increase bago pressure decrease. They had a difference in the value of work. Okay? So, that is for state and path functions. So, other elements of thermodynamics, we have to consider ano ba yung i-observe natin at kung nasaan ba tayo doon sa buong universe ng thermodynamics. Because universe is everything. It involves the observer, the observed, and the rest of the elements that there is in the process or in the system. Okay? So, sa universe, meron tayong tinatawag na system. Ito yung ating ino-observe. And the rest that is not involved in the system or not included in the system is called the surroundings. Between the system and the surroundings is an imaginary boundary. Okay? So, yung boundary na yan, dinedescribe na ng boundary na yan kung saan nagtatapos ang ating system at kung saan nagsa-start yung surroundings. So, dyan din natin na we-witness yung exchange ng energy between system and surroundings. Also, exchange of matter. Okay? So, for the system, we have matter. So, matter is anything that has mass and volume. So, it has mass and it occupies space. So, that's the most basic definition of matter. So, for the energy is either heat or work. So, heat is energy that is dissipative. Okay? So, ang ibig sabihin niyan, kumakalat lang siya. Wala siyang particular direction. Random ang kanyang pag-spread or pag-transfer. So, yung work naman, W, this is directed. Okay? So, naka-target sa isang particular system or the particular observation or particular substance, yung work na yan. Okay? Yung work na to ay may direction from the from the source, okay, to the receiver. Okay? That's why this is a vector quantity work. So, there are types of systems. So, meron tayong open, closed, and isolated. So, if this is the system, okay, and if you can exchange matter and heat, okay, or energy, this is called an open system. So, this is open. Okay? Kapag ka ang na-exchange mo lang ay heat, okay, kapag ka ang papalitan mo lang ay heat, tapos yung matter ay hindi makapass through the boundary, okay? Siyempre, kapag ka ganyang situation, yung matter inside the system hindi rin pwedeng lumabas. Okay? Pero yung heat na kapag transfer siya in and out of the system, this is called a closed system naman. Okay? Yun yung closed system. matter hindi pwede mag-transfer in and out of the system, pero yung heat pwede. Paano kapag both heat and matter, okay, cannot pass? So, heat and matter. Hindi sila pwedeng mag-cross dun sa boundary. Okay? Ganun din yung heat and matter dun sa loob ng system. So, ang tawag doon ay isolated. So, kapag hindi makakross sa boundary yung both yung heat tsaka yung matter, that is called an isolated system. Okay? So, that's a tough boundary kasi wala talaga nakaka-cross doon. Okay? So, that is for the system. So, let's talk about the boundary. So, boundary, let's draw a certain imaginary boundary here. Okay? Nandito yung system, surroundings. Okay? So, syempre, kapag may tinatawag tayong situation kung saan yung system and surroundings mo, yung exchange nila ng matter at energy, nagkakaroon ng net equilibrium or zero net transfer. Okay? So, kapag may zero net transfer na tayo ng heat or matter, nandun na tayo sa tinatawag na equilibrium. Okay? So, equilibrium is defined as the state wherein there is no apparent change in the amounts of either energy or matter or any particular work in and out of the system. Okay? So, yung pagpunta, for example, ng heat outside the system is equal to the heat that is being absorbed by the system as well. So, kung equal yung amount ina-expel niya dun sa kanyang ina-absorb, wala tayong makikitang net change in the heat of the system. Okay? So, that's equilibrium. Ano ibig sabihin pag mechanical equilibrium? So, kapag mechanical equilibrium, okay, yung pressure inside the system is equal to the pressure outside the system. Okay? So, P surroundings, P system. Okay? If the pressure inside and outside the system are equal, so wala tayong makikitang force, net expansion, or contraction na mangyayari sa system kasi yung pressure nila ay equal. However, may tinatawag tayong reversible expansion or compression. So, kapag sinabing reversible expansion or compression, may expansion and compression na nangyayari, pero yung P surroundings tsaka P system, equal sila palagi habang nag-e-expand or nagko-contract ng system. Ibig sabihin, yung rate ng expansion or contraction dyan, sobrang liit. Kasi kung masyadong malaki yung difference ng pressure from one expansion moment to another, syempre magkakaroon ka ng difference ng pressure sa surroundings saka sa system. So, to be able to do this particular reversible expansion or compression, dapat sobrang liit ng mga changes in pressure inside or outside the system. Okay? Sobrang liit na interval na yon, ma-maintain mo yung tinatawag nating mechanical equilibrium. So, mechanical equilibrium is denoted by the equal amounts of pressure inside and outside the system. Okay? So, next is yung thermal equilibrium naman. So, what is thermal equilibrium? Kapag ang equal naman dito ay temperature, okay? Kapag equal ang temperature inside and outside the system, so wala tayong nakikitang heat flow. So, walang heat na pumapasok sa system, wala ring heat na lumalabas sa system. Actually, that's just apparent. Meron talagang heat na pumapasok sa system, pero yung heat, okay, na pumapasok sa system is equal to the heat that comes out of the system as well. Okay? Yung exchange ng heat parang equal lang. So, pareho sila ng temperature. Okay? Wala tayong net flow of heat. Yun yung ibig sabihin ng thermal equilibrium. So, na-attain natin yung thermal equilibrium kapag equal yung temperature ng system and surroundings. This is according to the zeroth law of thermodynamics. Okay? So, meron tayong pangatlong type na equilibrium. This is material equilibrium. So, material equilibrium is an equilibrium situation wherein the net transfer of mass, okay, is equal in and out the system. So, yung papasok na mass, okay, sa system is equal to the mass that is expelled out of the system. So, ang pinakasikat na definition natin dito ay yung chemical equilibrium. Okay? So, kapag may chemical equilibrium ka, the rate or the amount of B that is being formed is equal to the amount of A that is being formed. Okay? So, in and out of the system. So, kung yung may M amounts ng A na nagiging B, so may M amounts din ng B na nagiging A at the same time. So, yun yung ibig sabihin ng material equilibrium. Actually, in this case, material equilibrium and chemical equilibrium are the same. So, may dinedefine tayong particular constant, the equilibrium constant. If the equilibrium constant is equal to the reaction quotient of this particular reaction, ibig sabihin, nasa material equilibrium yung iyong system. Okay, so we'll discuss this in the future. So finally, we have the surroundings. So sa surroundings, we are actually performing calorimetry. So calorimetry is performed outside the system. Kasi hindi natin pwedeng ipasok yung sarili natin as observers dun sa mismong system. So yung changes ng system, okay, ma-observe lang natin yan dahil may mga changes din outside the system. So that's the surroundings. Yung corresponding change ng surroundings, yun lang yung ino-observe natin through calorimetry. Okay? Yung mga calorimeters na tinatawag natin or yung mga thermometers na ginagamit natin pang measure, mini-measure lang niya yung changes ng temperature sa surroundings, not inside the system. Kasi pag nilagay mo yung thermometer inside the system, it becomes the system itself. Okay? So, hindi pwede yun. Kailangan, magkaroon lang tayo ng, kumbaga, implication. Okay? Hindi natin pwedeng directly itusok yung thermometer inside the system. That's why in calorimetry, you observe the change in the heat inside the system by observing the temperature change of the water that surrounds the calorimeter. Okay, din, at least doon tayo sa coffee cup calorimetry. Pag nagbabago yung temperature ng water doon, ibig sabihin may nagbabago ring temperature inside the system. And we relate those changes through particular calorimetric equations. Okay, so heat, okay, is denoted by the symbol Q or small q, while work is denoted by the symbol W. So, anything that is going inside the system, kapag papunta siya sa system, positive yon. So, kapag input, positive Q and positive W. Kapag naman output, negative Q, negative W. Okay? So, negative kapag palabas ng system, positive pag papasok ng system. So, let me emphasize on work. So, for example, meron kang piston. Okay? So, we know that work is equal to P dV, di ba? However, we need to change the sign of work kasi we have this. Okay? We have this particular convention. So, kapag ka nag-input ka kasi ng work, okay? Kung nag-input ka ng pressure, yung delta V mo ay bumababa. Okay? So, negative yung iyong dV. But the work is positive. So, therefore, work, okay, yung change in the work done is equal to negative P dV. Dapat ganun. Okay? Since kapag positive yung work, negative yung iyong change in volume. Kasi tinutulak mo yung system. Okay? Pag tinutulak mo yung system, lumiliit ang volume niya. So, kapag ka naman yung system mo yung nagpa-perform ng work, okay? So, maglagay tayong piston. Pagka nagpa-perform naman siya ng work, okay, pressure, yung work mo ay negative W, yung increase mo ng volume ay positive. So, this will also apply here. Okay? Ganun din yung mangyayari. So, our convention for the formula of work is equal to negative integral of P times the change in the volume. This is for reversible process. If P is constant, okay, work is equal to negative P external times integral of dV. Kung meron man V function or just delta V kung V2 minus V1 lang siya. Okay? So, this P is P of the gas or P of the system. Okay? So, kasi kapag P system is equal to P surroundings, this is called reversible work. Again, kapag reversible work, meron tayong material or mechanical equilibrium. Okay? This P here is always the P that is pushing. Yun yung surroundings yan. Okay? If P system is equal to P surroundings, syempre nag-iiba yung pressure kapag nag-iiba yung volume. You have to integrate. Okay? So, yun yung reversible work. This is non-reversible work kasi meron tayong constant na P external. So, magkaiba na agad yung external pressure dun sa pressure inside the gas. Okay? So, that is for the elements of thermodynamics. So see you next video.